Hello and welcome to GeneLab Chats. Today we have the privilege of interviewing Dr. Borja Barbero Barcero from Texas A&M University. The study of the effect of spaceflight on human telomeres has received great attention for many years, but the study of plant telomeres is largely unexplored. Dr. Barbero and his colleagues discovered that even though Arabidopsis plants sent to space and in follow-up studies on Earth show no change in their telomere length, their roots experience a significant boost in telomerase activity, among other interesting findings. In this interview, Dr. Barbero describes how the GeneLab data systems and the analysis working groups contributed to this publication. Thank you for joining us, Dr. Barbero. Could you please highlight the most important finding in your study?
Yes, absolutely. So when we started looking at the plant telomeres of plants that were flown to International Space Station, we actually expected a similar phenotype to what was observed in human telomeres, where in the twin study experiment and other related experiments of astronauts, they all experienced telomere lengthening occurring. However, what we observed is that our plant telomeres remain the same compared with the ground control. So that was pretty shocking to us. And then even more especially, we observed that there was an increase in telomerase activity. We did not expect to see that, especially in humans, that telomerase activity directly correlates with telomere length. So the more telomerase activity, the longer your telomeres often are in humans. However, we did observe a telomerase activity increase in Arabidopsis thaliana plants flown aboard the ISS, and that did not correlate with telomere length. So we started hypothesizing why that could be. We observed that there was increase in genome oxidation in our plants. So now we're hypothesizing, based on the ground studies as you were mentioning, that telomerase activity might be necessary to protect plants from the genome oxidation that they are experiencing aboard the International Space Station. And that's exactly what we observed on the ground experiments. We observed that mutants that were created in the CPL lab with an increased telomerase activity had a lower level of genome oxidation. So that was pretty much the most important result that we obtained, that there was an inverse correlation in telomerase activity to genome oxidation and no changes in telomere length in plants aboard the International Space Station.
Thank you for sharing that highlight with us. My second question is, how did the GeneLab data systems or the AWGs help assist you in your work so you could achieve these goals?
Yes, absolutely. So it's a pretty funny story of how the collaboration started. So we were first approached by an Argentinian physicist called Roberto Aquilano, asking if somebody had looked at plant telomeres in the ISS, and this is mostly motivated by the famous twin study experiment. And then we reached out to a colleague of Dr. Dorothy Sippen, Susan Bailey at Colorado State University, one of the PIs for the telomere length studies in the twin study experiment. And then she suggested that we should reach out to NASA Plant GeneLab group, that there might be different groups that may have tissues available for us. So we reached out, and I remember getting emails from Dr. Barker, as well from Ryan Scott, and then we eventually got an email from Dr. Sarah Wyatt and Dr. Imara Pereira saying that they have an upcoming flight and they may have tissue left over from those experiments. And that's basically how we were able to perform these experiments, just from being scientists being able to share their tissue and resources after flight. So these studies would not have been possible without the help of GeneLab and the open data repository.
Thank you, Dr. Barbero, for sharing that with us. That was a wonderful story to hear, and I'm really glad that that worked out for you. We appreciate the time you spent to share this information with us and with our viewers. And to our audience out there, you can learn more about this work, how to join the analysis working groups, and access the data sets analyzed in this work with the links provided in the description section below. Thank you and have a wonderful day.